If a game is going to have infinite levels, it's going to need procedural generation. Procedural generation is the act of procedurally generating things. In my upcoming 3D mining game, this means having each cave floor be automatically created whenever the player starts playing. I knew this was going to be the first thing I worked on for my game because, frankly, I had no idea how to do it and I wanted to just get it done out of the way. But with the power of research, aka YouTube tutorials, I've composed a system which works really well, using a combination of different methods and algorithms. I hope you enjoyed the video, and hopefully you'll learn something that you didn't already know. The first thing I came across was the random walker algorithm. I found this was used a lot to generate dungeons, with genres like roguelikes using it a lot. While I was making caves instead of dungeons, the idea seems similar enough. It essentially works by creating a walker object in the center of a grid. These walkers each have a random direction when they're created. They move forward a tile, setting it to a floor, and then it has a random chance to change direction, kill itself, or create another walker in its location. This repeats until all the walkers are gone, or until a specified percentage of the grid has been filled. The result can vary a lot depending on certain inputs. For example, I can control if the cave is really long and winding, or I can change it to be smaller and more concise. But generally you get a pretty decent shape, although it's quite jagged. It definitely has a lot of issues, like a lot of 1x1 gaps, random black tiles, and just generally it doesn't feel particularly natural for a cave. I knew I wanted to do more, but I wasn't really sure what. Looked into it some more, saw how other people built off their random walker algorithm, and I came across this random Reddit post. This post sent me in the right direction, that direction being Cellular automata. Now, what is Cellular automata, you may ask? It's actually mind-numbingly simple. Loop through every tile on the grid and change it based on a set of rules. In this case, those rules are how many tiles around it are walls or floors. If there's more than 4 walls around this tile, set this tile to a wall. If not, let it be a floor. As you can see, this has an immediate effect on the generated shape, improves it massively. And it works even better if you run it multiple times. In these examples I'm running it 3 times, just to ensure that there's no weird things left over. It's starting to feel like an actual cave. So perfect, we're done. Let's move on to something more fun. Let's give our main character jiggle Wait, what's that? And that leads us to our next major problem, unconnected areas. This was pretty difficult to do. There were many parts I wasn't really sure how to deal with. The first part that stumped me was, how do I even figure out if a room is unconnected? And then how do I track down where that room is? That's where flood fill comes in. This is another pretty simple algorithm, one that's commonly used by things like the fill tool in Paint. It basically checks a tile, then checks which of the 4 adjacent tiles are floors. It then repeats that process for each surrounding tile, marking them as checked in the process to make sure it doesn't get checked again. Once it runs out of connected tiles, that means it's filled the whole room. Repeat that for every tile in the grid, storing each room in a list, and then eventually that list will be filled with every room. So great, now I can figure out if there's an unconnected room, but what do I do with that room? I guess I could delete it, but then what if the room is massive and you just lose a massive chunk of the cave? Ideally, I'd have a way to connect the rooms so that the size of the cave stays the same. This was not easy, but luckily Sebastian Lague came in clutch with his great cave generation series, which I highly recommend checking out if you're interested. I'm not going to go into much detail because his series does a much better job explaining, but the algorithm essentially checks the edges of each room and matches it with the closest edge from another room. It then draws a line of floors from these edges, connecting the rooms, and then it repeats it again to make sure no rooms are left unconnected. So now we have a consistent cave shape being generated, and I'm happy with how it looks. There were some aspects I wasn't happy with, like 1 block wide ridges in the walls, or some floors that were completely encased with walls. So I did create my own little algorithm that just loops through all the tiles and changes them based on those rules, and that ended up fixing those problems. I then also added a quick system that chooses a random floor tile to set each tile, so it doesn't look as ugly anymore. That's not quite it though, since there's actually nothing in the cave yet. Now we're going to figure out how to actually put stuff in the cave. The gameplay for my game will consist of an entrance that the player starts from, and an exit they need to reach. How would I go about choosing where to place these points? Ideally they'd have a good distance between them so that the player would have to travel a good amount. With that, the idea came to mind that I would find 2 tiles with the furthest distance and have them set to those tiles. Implementing this was fairly simple. I iterated through every edge tile of the room, found the vector 3 distance between it and all other tiles, and whichever combination of tiles ended up being the furthest were the 2 results. However, I quickly realised that using this distance wouldn't really suffice. The only thing that the algorithm could use was the distance. It wouldn't be able to account for things such as walls in the way. So it could use the furthest distance on the grid, but the actual furthest walkable distance could be right behind a wall next to where the spawn is. Finding the furthest walkable tile was fairly simple. It actually uses the same algorithm as flood fill, a breadth first search. This is just that process of checking every connected tile, but here instead it marks the distance and then chooses the highest one at the end. This worked great, and wait, does it say 1000 milliseconds? Yeah, that's not ideal. My older system of just looping through all the tiles and checking the vector distance worked fine because that was just a simple calculation. But looping through every tile and performing a breadth first search is absolutely dreadful for performance. It should not take a second just to do a simple position calculation for 2 tiles. And this is 1 second on my PC. It could take way longer on a crappy phone. I definitely had to think of a better system, but I kinda had no idea how to fix it, without ruining the effectiveness of the calculation at least. So I went where no man should ever go, a place of witchcraft and dark magic. I asked ChatGPT, and that actually gave me a perfect solution. It taught me a smart way to only have to run the search twice. First, I choose a random tile on the grid, then I find the furthest tile from that tile. That gives me the entrance, as it's guaranteed to be one of the 2 furthest tiles on the grid. I can then find the furthest tile from that tile and boom, I have both tiles. It was really that simple, and I never would have come up with it without my robot friend. Although I still hate him. I was really in the end game now, although the only thing left was generating mineable tiles. I could have settled on just looping through and setting each one based on a random value, but I wanted a more flexible system that would allow for things like clumps of ores and large gaps between the ores. So I made room for the king of procedural generation, Perlin noise. Perlin noise is basically just a map of random blended values from 0 to 1. You can see in these examples where 0 is black and 1 is white, with the values in between being shades of grey. You can just measure a pixel and check if its value is higher or greater than the specified value. For example, in this noise map, if you removed all the values below 0.5, you'd be left with this. Unity makes this very easy to do, as the math class contains an easy to use Perlin noise function. So I can just create a noise map, scale it down so it matches the cave size, and then when I'm setting the tile, I can check the value and set the tile accordingly. So boom, finally done. And I'm pretty happy with it. The caves feel very natural in their shape, and it allows for ideal gameplay and pretty consistent designs. It also has a pretty good distribution of tiles inside it. It's also super adjustable, so depending on the type of level I want to make, I can generate the perfect shape for it. I adapted a lot of the settings to use scriptable objects, which basically means I can create assets with the specific settings for each level, which would be super helpful long term. It was a lot of fun looking into these algorithms and being able to combine them all together to create my own Frankenstein algorithm. There are so many areas of procedural generation I didn't even cover, and I highly recommend checking out the channels WhiteBoxDev and IndividualKex, as they have some really interesting videos on the topic if you want to look into it more. Thanks so much for watching. And feel free to follow my social media platforms if you're interested in the game I'm making. Hopefully I'll make another devlog, maybe I'll get lazy, who knows. See you next time.